So in this video, we're going to solve this triangle where alpha is equal to 35 degrees, C is equal to 5 inches, and A is equal to 3.5 inches. From our last video, we actually already know this has two solutions, but I'm going to pretend I don't know that. And I'm going to approach this like I just saw this problem and I don't know how many solutions it has, so that I can talk about how I would discover that if I just met this problem without having to actually measure things out and see a to scale diagram. So to start, I'm just going to draw a triangle based on the information I have. I do like to draw angles first, so imagine that 35-degree angle. So that's where A and alpha are, right? Because alpha is 35 degrees. I know A has to be the side across from all that, so I'm going to let this side I drew be C. And this time I'm not worrying about drawing things to scale too much. All right, well that means big C is down here, so this must be vertex B. And I'm just going to pretend there's a solution that looks like this. From our last video, I know there really is one, but little b living down here, and I need to find that. And I know A is 3.5 inches, so clearly not to scale anymore, right? That's too long, that's too short, but we're just going to go with it and pretend that that's a good enough picture, because all I need to know is what's across from what else, right? To know that the 35-degree angle is across from little a, and that 5 inches is across from gamma, and the law of sines will help me with the rest. To use the law of sines, I always need to know an angle and a side across from each other, so I know I'm going to use this bit of information. And then since I know side C, I'm going to find angle gamma first. So I'm going to think that the sine of gamma over 5 inches over C is equal to the sine of 35 degrees over 3.5 inches. Well, this is the first time I've used the law of sines where it's flipped, right, with the angle parts on top. And of course, we could solve it no matter how we wrote it down. It's just convenient to put the thing we don't know on top. And so very quickly, I could write that the sine of gamma is equal to 5 times the sine of 35 degrees over 3.5. I could grab my calculator and I could think to myself, well, 5 times the sine of 35, 5 times the sine of 35 over 3.5 is about that number. And so just for right now, I'm going to write the sine of gamma is about 0.819. Now, I'm not going to ever type 0.819 into my calculator. I'm going to use all the decimal places the calculator can hold to make my answer as precise and accurate as possible. But what I want to think about right now is that this says sine of gamma is equal to about 0.8. And if I think about my unit circle, there are two places where sine is positive in the first quadrant and second quadrant. About 0.8 would look like that. And so it's like there are two possible answers. One that is acute and one second quadrant angle that is obtuse. So I want to write both of those possibilities down. And it's just in this imagining that now I see why there might be two gammas that work. One that's acute, and then one over here that might be obtuse. All right, for the acute angle, we can use our graphing calculators and inverse sine to find it. Inverse sine can only tell me that acute angle, 55.0 degrees. That's like a little gamma 1. And if I think about now that obtuse angle, well, I know that 55-degree angle would be its reference angle. So 180, right, to there, and back up that 55 would find that obtuse angle. So that would be 125, and again, rounded there to that 0.0. So I have two possibilities for gamma. And now I just ask myself, can they both work? Well, the acute angle is fine. If this one's a little 55-degree angle, I say, well, 55 plus 35 is 90. Well, hey, there's enough room left over up here for a beta. In fact, what would beta 1 be? Well, if I have a 35-degree angle and a 55-degree angle, well, 180, probably don't need a calculator for this, minus that 90.0 is 90. We do need to remember this is not actually a right triangle because we've rounded, right, to one decimal place that looks like a right angle. If I drew this to scale, apparently that would be a very straight side there. but we need to realize it's not actually a right triangle. It's just off of it, right? Because we rounded just a little bit. All right, and then beta 2. Well, let's see. That's if I had a 35-degree angle and a 125-degree angle, right? That obtuse angle there. Well, if I add that together, I get 160, which would leave 20 degrees left over to form a third angle. This is the moment where I know I have a second possible solution, because that obtuse angle can fit in a triangle with 135. In our next example, we'll see when we get to this step that we add two angles together and we get a number that's too big, larger than 180. So there's no room left over for a third angle. So we'll see that in a moment. But the moment I add those two angles, the obtuse angle and the one I was given in the triangle together, and it's less than 180, I know there's enough room left over for a third angle, and I can have two solutions. Well, let's see here. What all have we found so far? Well, I was given alpha. I have beta 1 and gamma 1, beta 2 and gamma 2. So in the triangle with acute angles, with an acute angle down here, I'm only missing little b. So it's like I need to find little b1 to complete the story. And then in the triangle that has the obtuse angle in it, formed by swinging that side over there, I'm missing also b, so little b2. So b1, long side, right, in the triangle with acute angles in it, with that acute angle, b2 is a shorter length in this little triangle here, with that big fat obtuse angle in it. Well, let's find b1 and b2, using, of course, the law of sines. So thinking about b1, right? b1 over the sine of beta 1, which is almost 90 degrees, and I am going to use that rounded figure here, is equal to, well, thinking about this great big triangle, I should try to use the given information, so I'm going to use alpha and a. 3.5 over the sine of 35 degrees. Well, since I'm using that rounded figure, I know the sine of 90 degrees is 1, so this is just 3.5 over the sine of 35 degrees. I suppose if I was having a bad day, and if I throw in the sine of 90 here, because I multiply both sides by the same thing to get b1 by itself, at least I don't get it wrong. But sine of 90 degrees is 1, so I didn't need to do that. And little b1 is 6.1. What were my units? These were inches. And so just to make things look nice, I'm going to put little b1 written down here, so I see 3 parts that complete the first solution. All right, little b2, obtuse angle. Excuse me, little b2, little acute angle up there. So beta 2 is 20 degrees, sine of 20 degrees. So I'm looking at little b2 and that angle beta up there. And again, I can use the given information, and that's still a 35-degree angle. And A, that swinging side, is still 3.5 inches long. So I have the same job to do. Let's multiply both sides by 20, so I could think about the sine of 20 times 35. 3.5 over the sine of 35 degrees. And little b2 is approximately 2.1 inches. And again, when you're doing homework problems, lab problems, or any problems, follow the rounding instructions given. I wasn't given any here, so I'm just going to round to 1 decimal place because it feels right. I have a first triangle and a second triangle, and we have found both solutions. And anytime we see the instructions solved, we should be thinking about finding every possible solution. And that second solution happened right here, where I said, well, this gamma 1 came from inverse sine. Inverse sine has a range between minus pi halves and positive pi halves, so it could only tell me that first quadrant. The inverse sine of 0.81 can only be a first quadrant angle. I have to think about that as a reference angle to cook up the second possible angle. Think about the angle it's in the triangle with and say, hey, is there enough room left over for a third angle? And with these two, 35 and 125 make 160, and I can have that third angle. In our next video, we'll see one that only has one solution, and in the one after that, we will see one with no solutions. But that's it for now.